Hello again, everybody. Continuing on in Chapter 5, we're going to start with Section 5.1, talking about rational exponents and nth roots. So, the radical. Remember, the radical is a symbol for finding the root of a number. This could be a square root, a cube root, a fourth root, a fifth root, so on and so forth. So, we have square root, cube root, fourth root, fifth root. So remember, the number on the pedestal, with the exception of the square root, because we don't put the 2 there, tells you which root it is. For all even roots, if a underneath the radical, whatever number it is positive, then you have 2 real answers, one positive and one negative. That's for an even root. Remember, even is 2, 4, 6, 8, 10. If your value underneath an even root is 0, your answer is 0. There's no positive or negative for that because 0 doesn't have a positive and negative value. If your value underneath the radical for an even root is negative, you can still take the root, but remember you need the letter I because there are no real roots. I is equal to the square root of -1. If you have an odd root and your value underneath the root is positive, then you have one answer that is positive. If you have a 0 underneath an odd root, the answer is still 0. And if your value underneath the odd root is negative, then it has one real root that is negative. We don't use I in this case. So, finding the fourth root of 16. Well, 16 is positive, so we know we have a plus or a minus. And then what number times itself 4 times is 16? And that's 2. If you're not sure, then we can take the 16, and remember the 4 tells me we need a set of 4 in order for the numbers to be able to leave the house. And so when I break 16 down, I have one set of 4 2's. Number 2, the third root of -27. So we know from what we just talked about up here that our answer is going to be negative because of the negative here in front of 27. The third root says what number times itself 3 times is 27. And that's going to be 3. And again, if you're not sure about that, then take the 27 and break it down. Breaks down to 9 and 3, and then 3 times 3 times 3. So I have one set of 3 3's. All right, number 3, the sixth root of -64. Well, 6 is an even number, and there's a negative here. So I know I'm going to have to pull out I. I know also because 6 is even that I'm going to have a plus or a minus. So what number times itself 6 times is 64? And that answer is 2. And then number 4, the fifth root. So 5 is odd. That means we only have one answer. 32 is positive, so we're going to take the positive answer of what number times itself 5 times is 32. And that answer is 2. All right, we are going to skip over these, and we'll talk about those more in depth tomorrow in class. So, rational exponents. Can we figure out how to type the third root of 216 into the calculator? Because I just am not sure that I'm going to be able to figure that out on my own. What about the seventh root of negative 536 to the second power? Well, there is a way, and it's by using rational exponents. Rational exponents, when we rewrite them, are power over root. This right here, power over root, or the exponent over the root, you want to make sure you memorize. Now again, we don't ask you to memorize a whole ton, but you do need to memorize this. Power over root. To rewrite it into rational exponent form, which then allows me to type this into the calculator. The third root of 216. Remember, 216 doesn't have an exponent here, but we know that the exponent is 1. So we can rewrite that as 216 to the 1/3 power. That's the first power over the third root. Negative 536 to the second power and the 7th root. So that's to the 2/7 power. To type them in our calculators, we use the caret button. The caret button, if you have an 84, is going to be right above the division key. But that symbol is on a button on the Casios, and then also if you have a TI-30 or any other type of scientific calculator. So we type 216 caret parentheses 1 divided by 3 into our calculator, and we should get 6. Negative 536 caret 2 divided by 7. All of these parts in parentheses here. And we get a decimal. So let's take it to the hundredths place. And that'll be 6.02. So let's try these in our calculators. 6 to the 2/5 power. Remember, round them to the hundredths place. We get 2.05, or 2 5/100. 64 to the negative 2/3 power. Remember, that negative never makes a negative answer. We just know that it should be small, which it is. It's 0.0625. The next one, if we rewrote that in power over root form, that would be 16 to the 5/4 power, which is 32. And then the last one, we have negative 30 to the 2/3 power, which is about 9.66. So now we have variables coming in, and we're going to solve equations with these rational exponents. We're going to use backwards order of operations to solve them, just like a regular old equation, SEDMA. It's just that in order to solve them, we need to use the reciprocal power for opposite operations. Remember, reciprocals are taking your fractions and flipping it. So if I had 4/5, the reciprocal is 5/4. If I had negative 2/9, that reciprocal would be negative 9/2. If your original exponent, that's the number on top of your fraction, was even, then you have two answers, a positive and a negative one. All right? And then round all answers, unless they tell you otherwise in the directions, to the 100th place. So let's take a look at a couple of problems. X to the 4th is equal to 60. Well, the only thing that I have to move away from my x is that 4th power. So first of all, 4 is an even number, which means we're going to have two answers for this. And then what is the reciprocal of 4? Well, remember, 4 is the same as 4 over 1. So the reciprocal would be 1/4. So 1/4 and 60 to the 1/4 power. We're going to put a plus minus here. So in my calculator, I'm doing 60 caret parentheses 1 divided by 4, or 60 caret 0.25, because remember 1/4 is the same as 0.25. And to the 100th place, you get 2.78. Letter B. I have to get rid of that 1/2. I look at the 1. That's an odd number, so I'm only going to have one answer. The reciprocal of 1/2 is 2, and 12 squared is 144. Letter C. Well, let's see. We've got parentheses, exponents, and multiplication. So the first thing I have to do is divide by 2. It gives me x plus 2 cubed is equal to 27. 3 is an odd exponent, so I'm only going to have one answer. And the reciprocal of 3 is 1/3. So x plus 2 comes out of the parentheses, and 27 to the 1/3 power is 3. Subtract 2 to finish getting x alone, and we get x is equal to 1. Letter D. I'm going to change colors here. So we have parentheses and exponents. The exponents have to go away first. 2 is an even number. So that means when I do my exponent, I'm going to have two answers, plus or minus. The reciprocal of 2/5 is 5/2. So I'm going to take both sides to the 5/2 power. And on the left, the 2/5 and the 5/2 simplify to 1. So we're left with the x minus 6 plus or minus, and 37 to the 5/2 is 8,327.3. Now to finish getting x alone, I have to add 6 to both sides. Now be careful. I am adding 6 to a positive 8,327.3, which is 8,333.3. And then I'm also adding it to a negative 8,327.3, which is negative 8,321.3. So those are my two answers. Remember, with the pluses and minuses, you can't always say it's just going to be plus minus whatever with 6. Those are two different values that we're adding 6 to. Example E. let's see, I'm multiplying by a third. I have an exponent of 3, and then I'm adding 23. So to work backwards, I'm going to start with subtracting 23. So I have 1/3, x to the third is equal to 2130. 1 divided by 3. The opposite of dividing by 3 is multiplying by 3 on both sides. So that leaves us with x cubed is equal to 0.93, 6,390. Now, this problem, I want you to finish on your own. That answer is what I'll be checking for homework points tomorrow. And then our last example, letter F. I'm going to start with subtracting the 6. So we have 2x to the negative 1/2 is equal to 10. I'm going to divide by 2. So x to the negative 1/2 is equal to 5. Now I have to do the reciprocal of negative 1/2. First I check the top. 1 is odd, so I'm only going to have one answer. And the reciprocal of negative 1/2 is negative 2. So 5 to the negative second power is the same as 1 over 5 squared. Remember, once it flips the number, the negative goes away because it did its job. And so I have 1 over 25. All right, that's it for section 1, everybody. Have a great night.